My name is Alan Hawes, and this is PSoC 101. In this lesson, I'm going to show you how to generate and handle an interrupt from the PSoC hardware. In this project, you will attach an input pin to an interrupt, and then use an interrupt service routine to toggle the state of an LED. As before, make a copy of the input pin project first. I'm going to make the input pin generate an interrupt. In the customizer, navigate to the Input tab. Then select the interrupt to be on a falling edge. That corresponds to a press of the button because the Pioneer kit switch is active low. You'll see an IRQ terminal appear on the bottom of the pin. Now search for an interrupt component and drag it into the schematic. Wire it up to the terminal and give it a sensible name. That's all we need to do in the design. The rest of the project is in C code, and to make that easier, I'll build the project to have PSoC Creator generate the APIs. The best way to become familiar with a component API is to look in its datasheet. Every component has a datasheet, and it can easily be accessed from many places in the PSoC Creator GUI. I usually just right-click on the component, but you can also do it with the button in the customizer or from the component catalog. There's a section in the datasheet called the Application Programming Interface. For the ISR component, you will see there is a start and a start EX function to install the handler and to enable the interrupt. You can use either one of these. The start function requires you add code to the generated source, which can be tricky if you're not used to it. I recommend that you use the start EX function as it allows you to provide the address of your own interrupt handler. When I first recorded this video, I didn't mention how the API functions were named, and that has tripped up a lot of new users, and I've gotten tons of email from you. It got so bad my own son was yelling at me. So I've added a new section here to explain how that works. The API functions in your code will start with the schematic instance name that you used, followed by the function name. Since the datasheet doesn't know the instance name that you used in your schematic, it just uses an assumed name. For example, if you look at the top of the API section of the interrupt datasheet, you will see that it uses the name ISR. Now, when we look at the startX function, you will see that it is listed as ISR _ startEX. In our schematic, we named the interrupt component pen _ SW2 _ INT. So our function will be pen _ SW2 _ INT _ startEX, as you'll see in a minute. First, I'll write the interrupt handler itself. I'll put it above main, so I do not need to set up a forward declaration for the function. We provide a compiler agnostic macro to help you set up the portable interrupt service routines. That macro is called CY _ ISR, and I invoke it with the name of my interrupt handler routine. The rest is just code for the ISR. I want to toggle the red LED on every button press. It turns on one time and then off one time. So I'll write the code to read, invert, and then write back the LED pin value. I also need to clear the interrupt, or the ISR will keep firing over and over forever. The interrupt is generated from the pin, so I'll open the pin datasheet and look at its APIs for a suitable function. In this case, it's called clear interrupt. Again, the datasheet function is listed as pen _ interrupt because it assumes the pin is named pin. But in our schematic, the pin is really named pen _ SW2, so the function name that I will call in my ISR is pen _ SW2 _ clear interrupt. Notice how the tool predicts your typing and helps you get the correct API call. After creating the handler, I will need to install it by calling the startEX function. Remember, the startEX function name starts with the interrupt component instance name. So I will use pen _ SW2 _ int _ startEX for the function name, and I will provide it the name of the interrupt handler function that I just created. You'll have noticed in the template main.c that we provide for you, there is a call to CY global int enable. This is a macro that turns on the global interrupts, so you'll need to make sure that that line is not commented out of your code, and that will make your project work. When I program the kit, I can toggle the pin by pressing the switch. Sometimes I find that it ignores my button presses though. This is because the switch is mechanical and it will bounce up and down again. This causes multiple interrupts. We could fix that by adding a debouncer component into our circuit, but we won't do this, and I'll explain that in a future lesson. When you make this project, try controlling two LEDs from a single ISR. As in the previous lesson, turn one LED on and the other off so they alternate when you press the switch. As always, you're welcome to email me at alan_hawes@cypress.com.